Hello everyone, my name is Akash Chandragupta and welcome to this lecture on operating system. In our last lecture, we looked into the very definition of operating system, the functions of an operating system, and the very basic unit of execution in a computer system, the process. What is it and what is the difference between a program and a process? And with this example, we understood that as a program it contains only one multiplication, but as a process it contains 10 multiplications. So now we just start with our other topics. The next topic is process block. So as I said, as a program it is nothing but a piece of text, but as a process it has many complexities associated with it for to be able to execute. So a process has various data structures to maintain. It has a stack, it has a heap, a data block, and a text block. So the stack part of the process block is responsible for function related information, like stack. When you are running a recursive function, all right, so stacks finds its application there, where you push your return address and continue with your inner function calls. Also we have heap in process block, which is helpful for dynamic memory allocations, which we normally do in C using malloc and calloc functions. There is data sections, which is used to store the global variables. There is a text section where we store the codes. Alright, this piece of text will be stored here. The allocation of variables, global variables, will be done in the data section. Any dynamic memory allocation will be done in the heap section, and the recursive function calls will be using the stack section. But point to note here is that stack and heap are variable in size. That is what these arrows indicates. As the recursive call size increases, this stack will grow. And similarly, when you dynamically allocates many variables, then the size of heap also grows. Then there is this process control block. Each process need to maintain some information. This process block was responsible for execution. All right, this is basically, you can say, accounting, maintaining informations like what is the process number of the process, how many registers are in use, how many open files, how many files are in use, how many files the process has opened, and all this information are maintained in this data structure called process control block. So a process control block is responsible for maintaining information related to its execution, like list of open files, registers in use, etc. Alright, so the informations required by a process for execution are maintained within this process control block. Process control block in an operating system is an operating system data structures which contain the state information of each process. So it is per process data structure. So the process control block of one process is different from the process control block of other process. All right, so now we see the process life cycle. As I said, program is just a piece of code, but when you execute that program is taken from the disk and copied into the main memory, and it started execution, and the execution of it is started. So while in execution, This process circulates through various stages. Alright, it process finds itself in various states as and when during its execution. So when a process is loaded into the main memory, it is in the new state. Alright, then when process is wanting to execute, is the process is willing to execute, then it is put into the ready queue where it is in the ready state. When the time comes, as large number of processes are waiting in the ready queue, when the time or turn of a process come, then the CPU is assigned to the process and process does its execution. Alright, when the process is executing, it is in the running state. Now interrupts may arises where process is interrupted. Suppose some higher priority process has arrived, then the currently running processes must be preempted or moved from the running state to the ready state, and that higher priority process must be assigned the CPU. But during execution, a process may require some IO operations also, like process is executing but it encounters that it requires some information from the disk. So what it does, its CPU does not wait ideally for the IO operations to complete. Rather, what it does, if a process requires any IO operation, then it is sent to the waiting state. Then that process is moved to the waiting state, whereby it can perform all its IO operations and then move again to the ready state. When this process is moved to the waiting state, new process, if present in the ready queue, is assigned the CPU. So CPU is kept busy as much as possible. So this is the IO event where suppose a process requires disk access, then a disk access can be performed in the waiting state and the process is moved to the ready queue after it has finished its IO. When a process completes its execution, then process is finally terminated. Alright, this is the whole process life cycle of a simple process. Here, as I said, we will do many questions so that it becomes very clear, not just theory, but we'll also solve the problems too. In the following process, this is a gate question actually. It gate 2009. All right. In the following process, state transition diagram. This is a state transition diagram. All right. Both these are almost the same, identical diagrams. For a uniprocessor system, assume that there are always some process in the ready state. There are some process because, as I said, there will be multiple processes waiting for the CPU. So when one process is running, other is waiting, like that. When here also it said assume that there are always some process in the ready state. Now consider the following statement. If a process makes a transition D, alright, the process is getting terminated, that is, it has completed its execution. So if a process makes a transition D, it would result in another process making transition A immediately. So it is saying a new process arrives in the ready state. This is not the case actually, because a process is getting terminated. What if the process getting terminated is the last process? last process required for our work. If that is the case, then there may not be any process coming in the start or the ready state. Alright, there may not be any process left out. So this one is false. A process P2 is in blocked state. Alright, as I said, IO operation is performed in the blocked state. You can also call it as waiting state or block state, both are same. Process P2 in block state can make transition E, means it has finished its execution and it's returning to the ready queue. Another process P1 is in running state. So P1 is in a process P2 in block state can make transition E while another process is in running state. Yes, this is true because when this is making a transition from when a process which was currently doing its IO operation and it's finished its IO and moving to the ready state, then there may be some process at the front of the queue, front of the ready queue, which is assigned uh, the CPU. So while some process is running, uh, the processes which were in the blocked state can be added to the ready queue at the back of the ready queue. So there is no such uh, relation with the processes running and process getting added. So when some process is running, no problem, this was an independent state. When the process finished its IO then and it is willing to perform some CPU execution, then it can be added to at the end of the ready queue. Next, this OS uses preemptive scheduling. Yes, this is also true because here you see, as I said, when higher priority process is arrived in the ready queue, which requires CPU just instantly, then the process which was currently under execution must be preempted, must be removed, the CPU from that process must be snatched and given to the higher priority process. So as we can see, there is a preemption happening here. So the OS uses preemptive scheduling. The OS uses non-preemptive scheduling. This one is wrong as 3 is right. So which one is true and which one is false? This one is false because the process which is making the transition D may be the last process. Therefore, there may not be any other process coming in making the transition A. A process P2 in block state can make transition E. As we discussed, there is no relation between the program under execution and the process getting added at the end of the queue. Therefore, the statement 2 is also correct. The OS uses preemptive scheduling. This is also correct. There is a preemption happening here, as we can see. But OS uses non-preemptive scheduling is wrong. Therefore, the correct option is 2 and 3 because 2 and 3 are true. Which of the following statements are true? So here we can see it's true. Now there is another concept, very important concept called context switching. Okay, we will cover it in our next lecture. This is also a very important topic as far as exams are concerned. So we will just cover it in the next lecture. Thank you.